So welcome everyone to our December PyData and Arbor event. So I just wanted to start off by acknowledging our sponsors. So NumFocus, who sponsors the Meetup, TD Ameritrade, who gives us this lovely space, and Midas for the food. And if you have any comments, questions, or want to tweet us, the Twitter handle and our email address are here at the bottom. We definitely do take suggestions and feedback about the Meetup. So some important points, there are emergency exits. So there's an emergency exit over here and then back out the way that you came. Like I said, feedback, I always preempt myself. And we are in a borrowed space and it's a lovely space and we'd like to keep using it. So please treat it like the guest that you are and help clean up after yourself. So Q&A. Unless quick, hold questions until the end. Please phrase your question in a form of a question. Try to keep questions to 30 seconds or less. Avoid long statements or monologues. And there will be time for open discussion after Q&A. I'm going to read our PyData Code of Conduct now. PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, religion, or experience. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds and levels of experience. Sexual language and imagery is not appropriate for any of our Meetup events. Be kind to others. Do not insult or put down other attendees. Behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the Meetup at the sole discretion of the Meetup organizers. Thank you for helping make this a welcoming, friendly event for all. So we're going to do a quick icebreaker. And our icebreaker provided by our speaker was snakes or lizards. So please turn to someone you do not know next to you, nearby, and discuss. Interpret it as you will. Snakes or lizards. We'll give you a couple minutes. Alrighty. I hope this has been an enlightening experience for everyone and you've met someone new and learned something new about them. So this month in data science, so there's a new podcast called Learning Bayesian Statistics, hosted by Alexandra Andorra. So take a look. There's, I think, 4 episodes or so. Take a listen. Take a look at the website, maybe, and then take a listen. You have to look at something. Anyway, so there are probably 4 episodes or so, and I hear that it's enlightening and interesting. I have not checked it out yet, but I will. And then our next event in January will be Eric Ma on testing data science code, and that will be Wednesday, January 15th at 6 p.m., same place. All right, so does anyone have any community announcements? So every month, for those who are new, because I know there's a couple of you, we invite folks in the community to make announcements about jobs they have, jobs they're looking for, general community events and announcements around in the data science and PyData community.
Real quick, we got some books, so by Matt Harrison and Michael Kennedy. You might have heard Michael Kennedy on Talk Python, Python Bytes. Matt Harrison has a lot of educational content related to Python as well. So thank you to them for sending these books to us. We're going to do a quick draw. Ben and I have each a number in our brains right now. So if you're interested, these are PyCharm related, so the IDE books and usage of them. If you're interested in one of these books, please raise your hand right now. We'll give it to her. Okay? Thank you.
Are there any other community announcements? Since Sean was so exciting and there was a game involved. Yes.
Can you stand up, please?
Yeah.
Hi everyone. I'm looking for jobs as a data analysis. My name is Ping. I'm now a master's student in programming and survey methodology. I also work as part-time for surveys of consumers. I'm familiar with SAS, R. I'm also using Python for course projects. So anyone has jobs suitable for me, please contact me. Thank you.
So Champaign here in the front, if anyone wants to come talk to him afterwards, please do. Well, please do anyway, but any other community announcements? Great. So, without further ado, Elizabeth Wickes is a lecturer at the School of Information Sciences at the University of Illinois, where she teaches programming, data curation, and information technology courses. She has previously been a data curation, curation manager, and data curator. There we go. She currently co-organizes the Champaign-Urbana Python user group and is serving on the Carpentries Executive Council for 2018 to 2020. Welcome.
All right. I've got the Google Slides closed captioning going, which is not like the best ever, but it's free and it's a button away. So we've got that going for it if you need. Thank you for coming out. I'm super excited to be here. The slides for this I've put up in Zenodo. Here's the DOI for that. I also just tweeted the link out as well. So this is gonna be a wild ride. Just to reiterate a little bit about myself, because context, I think, makes everything make more sense. I teach programming to grad students who are professional students, mostly library science. Do we have any library science people in the house? Crickets. Love it. Okay, fine. Carpentries people? Half a hand. I like it. I can get that. Okay. Yeah. I've co-organized the Python user group in Champaign-Urbana for like 6 years now. So we have a weekly meetup for just open work time. So I see a lot of beginners. I work professionally with a lot of beginners. Beginner independent learners are sort of my life at this point. And so my research areas are working with teaching people programming who live sort of outside of STEM. So like library science students generally come from humanities degrees, and so they have not had any programming experience before at all. But also independent learners, so people who are job changers or learning on the side, things like that, people who are sort of outside of the formal classroom. I'm also really interested in learning communities, communication and information resources, especially about programming communities as well. So how do we find information to answer our questions? How do we get the job done? I believe programming is a very information-centric practice. First information, secondary linguistic, third humanities, sort of. So that's my very unique take on things. I'm also really interested in investigating effective and sustainable data management and curation practices for research programmers as well, because it's hard. Documentation's hard, right? So how can we do it? What's the most minimal thing you can do that would be the most effective? Because that's frankly what we got. Let's figure out what it is, and let's start from that instead of starting from the beautiful world, okay? So, because the beautiful world, never gonna happen. I'm trained as a librarian, social scientist, and information professional. I have incredibly strong feelings about information resources, so some of that is gonna come out today. So briefly, what is information sciences? I was asked to explain this. I wish at some point in my life I could talk more just about my work and less about what my domain means, but it's okay, I'm here for it. Okay, so from the iSchool's mission statement, I forgot to turn on my timer for what's going on, so eventually I got yelled at. So from the iSchool's mission statement, we were focused on understanding the use of information in science, culture, society, commerce, and the diverse activities of our daily lives. So we are all over the place, but sort of really about how do people get things done. We talk about this sort of like the triangle of information, technology, and people, and these are the nodes that we really try to keep in focus in all of our research. You cannot forget about any of them. They need to be equal partners in how you're investigating the world. So what this comes down to is I cannot give tech talk without a huge portion talking about the human cost of screwing things up, right? We talk not about how to develop an algorithm, but how people are impacted by algorithms, for example. We're going to take care of some of that business now. We're going to revisit this a little bit later. This is going to be less of a technical talk. Like there's plenty of those. There's all kinds of things on YouTube. We're going to be technical, but don't fret. Like there will be some code, but you will not need to understand the code. Sort of grok what I'm after. We cannot inspect technical problems and code and things around that within a vacuum that ignores the humanity and the community context around those problems. Those are both vital communities. Humans make code. Code represents humans. This should not be a forgotten element of our work. Code is not neutral, and any problem or solution investigated around those lines needs to include the community elements that have created. Communities make problems, communities solve problems, because communities are humans, humans are the actors at question, okay? So I also want to make a strong point of order. I am going to be critical of some open source projects and documentation in this talk, but I want to strongly acknowledge I am not being critical of the people, the intention, or the effort behind those projects. It is hard. It is hard work. Maintainers put in a lot of effort, often, most of the time, uncompensated effort towards making these things work. I will reiterate what PyCon has been doing keynotes about for several years. If your company uses open source products, your company had better start, please, donating to those open source projects to sustain them, or donating your time to support them. It is hard, important work. I am grateful for the work that they put in, and I want us all to work together to make it better, okay? So with that, we are a community of practice. It is beautiful, it is wonderful. We are a community of human beings also around the globe. Python is huge all over the place. So we are also providers of situated learning within our communities, and that is sort of a really important point of a community of practice. Who are my beginners in the house? You're sort of beginning to Python, getting going with things. Welcome. You're all wonderful, and I'm so happy that you're here. You're here to learn, and we also need to learn from you about what you need and how we can better help things. So doing activities like being a mentor, being a supervisor, a team lead, a helpful colleague, providing formal and informal instruction, writing tutorials, reviewing books, attending things like this, giving talks, etc. This is all part of situated learning. We learn from each other across all levels. This is what makes us a community of practice. We are making a practice together. It's important. So together we learn and teach and share our values and provide these rubrics for identity. Like, who here like sort of identifies as like, I am a Python person, or Pythonista, or whatever word makes sense. Okay, a couple of hands. We'll get your hands up. Don't worry about that. The actions and practices that we showcase, like for example, reading the code of conduct at the very top of the talk, showcases what's normal and acceptable. Like, these are the boundaries and rules of our community, and we police them internally. And we police them by sort of this give and take of identity. Like, oh, you cannot be a Python person anymore if you violate these tenets of our community. Likewise, if we erase the representation and work of someone from a community, we're kind of erasing their identity, and that's really hurtful. So we need to be watchful for these things. And I know, but Wickes, we're here to talk about data, right? And Python maybe at some point, I know, we'll get there. The problem of not having numbers in your data is sort of twofold. One, your data doesn't often conform to the expectations of tutorials and things. And B, it's coming in from wild places, which is, I think, wonderful. I love those challenges. But it just means that the ramp up to being able to run like a bar chart on something is really hard. Okay? A lot of the tutorials that we publish are really problematic for people who are not coming in with spreadsheets. Okay? So I want to unpack in this talk, what does this cost us and cause in our community? Many will think, they try, like I got a folder of data, I got maybe some spreadsheets, I got some stuff, I've got a little bit of Python skills, okay, let's hit this. You Google some things, make bar chart in Python, something like that. You manage to get through all of the environment packaging stuff, and you're like, great, cool, I'm importing pandas. Life should be good from here, right? And then they hit a bunch of errors, and they have half an hour of errors, and what are you supposed to do at that point if you don't have a community around you, or you don't see yourself or your workflow in those documentations? So some people are going to think Python is just not for me, and they bail. Right? At every point in the road, you have a choice. You have a fork. You can either bail or you can dig deeper, right? Now, for some people, this might be, so some people also take this a little bit further and say, not only is Python not for me, but programming is not for me. Sometimes this is a fine call for that moment in time, and I have counseled people out of learning Python because another tool is going to provide the better value add for their time at that point. Right? It happens, right? So the cost of learning how to code might not meet the value of being able to code at that point in that person's life. And that's important to acknowledge. But for a lot of other people, this is a false negative when we've lost someone valuable, a valuable voice to our community. And the people that we have lost along the way should keep us up at night. We should be deeply concerned about the people we lose. So how have we gotten here? Got really heavy, really fast, I know, right? Okay, breathe. Okay, there's gonna be action items at the end. Are we ready for action items at 7 p.m.? Let's talk about some of the data that I interact with. What sort of data does library science have? We are super interdisciplinary, as you saw from that mission statement or heard from the mission statement. We have a lot of different coverage areas. So imagine things like huge bibliographic databases, like the entire library catalog, like not metadata just about one book, but about the entire catalog. That's a data set that we might work with. What I'm going to talk about here represents like maybe 10% of what we actually do, with 10% being completely made up, but to give you an idea that it's a tiny slice of what we actually talk about. So some people that I work with the entire corpus of PubMed Central. Some people work with just the bibliographic entries. Some people work with the entire text of those papers. The HathiTrust Research Center, HTRC, has metadata on 16.7 million volumes or books. So everything in Google Books that's scanned exists in this big old digital library. And so they've got not just data on the volume itself, but about each single page in that book. So each page is scanned in OCR, so they've got metadata about that page and about the words and pre-computed analytics about it. About, like, at this point, 20 million things. So we have a lot of really big stuff. We do have like actual books and other physical objects that we preserve and take care of. This also means that we have pest data and location and climate data, because you've got physical objects, you've got to like make sure they're not getting eaten by crickets, for example. Or like undergrads leaving crumbs. There's a reason we don't ask you to not eat food in the library. We work a lot with digital humanities, information modeling, provenance, prospective and retrospective as well, reproducibility, just like a lot of metadata happening. To give you a snapshot of just how like wild my world is, and I love it. Just inside the building where my office is, we've got the Center for Children's Books, which has a huge non-circulating collection of children's books. They do outreach and training and reviews and newsletters. The Center for Informatics, Research and Science and Scholarship, which does like a lot of social science around data and reproducibility things and data curation. And then the HathiTrust Research Center that I mentioned before. So it's a wonderful, broad landscape. But I was trying to think for this talk, like how to explain like what is iconically different about library science and information science data. It's often talking about physical objects, but less about the physicality of that object. But it's in there, like we talk about it, we have those measurements. But it's also more than just the content and the context. It's sort of everything meshed in together. It is insufficient to measure just the physical object. So like here's my prop, here's my planner, right? Does the physical measurements of this planner talk to its existence, represent it as an object? Yes, if I wanted to put it on a shelf, I would need to know the dimensions of it, but it's about what's inside, right? And it's not just about the content, right? It's also about how that content is presented and organized and used. So it's insufficient just to measure the object. It's also insufficient just to transcribe the content of it. Right? It's sort of hitting this delightful balance where how can you transform this physical object and semantic content into something that's computationally powerful, which means you have to balance this readability and authentic representation where you open up the file and you're like, that's a book, got it. Duck typing, still working, right? But you've made it into something that's computationally powerful. And I think that's what a lot of our data speaks to. So some examples of the data files that I work with, like just a lot of XML and HTML for web scraping as well, across a lot of different schemas and sometimes XML files with multiple schemas at play. So that's fun. Metadata about objects and collections, looking across the corpus itself. The whole corpus is the data set. We process a lot of free text, including subject heading, controlled and uncontrolled, and theoretically controlled vocabularies. Databases, APIs, a lot of giant, overly formatted Excel things, so many PDFs, you have no idea. And just as a snapshot, we're going to look at sort of 3 examples as well. So this is a project that I worked on at the library when I was there. we were trying to create this internal metadata schema to hold some data. And part of that schema was going to get punted out to the public into a metadata store. And we wanted to make sure that we were sort of in compliance, not just with the documentation, but with how the broader community was using the schema. Because the documentation was a little bit like, not sure what you're asking me to do there. So how are other people doing this, right? So this is an example of one of the records, and I was interested specifically in just this one element that's happening in here. You don't actually need to read it, just know that it's a small part of what's going on. So I hit the metadata store and got about 50,000 payload files, and those unpacked into about 3 million XML files. And so I sort of gathered what I could that made sense out of here as well, but I was just kind of profiling how is this element and attribute being used? What are they, how many people are using it, and who's putting it in? So this is actually an element necessary to hook a data set to the relevant paper for it. If anyone's into reproducibility, sort of this is really important for citation networks and things. What I ended up gathering was a lot of text data and some dates. Like the most numerical thing I had was like some dates happening in there. So what do these look like to you? ISBNs, right? But hey, we've got numbers. They're in a column. This looks like computationally promising, right? How do you think these are connected? So they're ISBNs, so they got to be like books of some form. But can you tell? Who knows, right? Unless you're an ISBN parser, like you're not going to know. These are actually books that were censored from a prison. So we have the Education Justice Project as part of the Danville Correctional Center in Illinois. And they are a college program that lives inside of the prison to let people take courses while they're serving their time. And that program had a library of about 4,000 books. And then all of a sudden one day, 202 got pulled. No explanation, no warning, just disappeared and went into like someone's trunk or something. It's been a couple years and we still don't really know why they were selected or what the reason was for pulling them. We're getting a lot of scattered things. These are the ISBNs of the books that were pulled. Okay, my colleague, Dr. Emily Knox, is an expert in book censorship and book banning, and she is investigating this, and I offered to do some data crunching for her. This all started as a big PDF of just like titles and authors. And then it turned into this column of ISBNs. And then of course that turned into XML files. So here's a little snapshot of that. I harvested the Library of Congress catalog record for all of these books and extracting subject tags, sort of these little chunks in here. Again, it's just text. Text with a little bit of hierarchy and structure, but just text. I also want to talk a bit about finding aids. So long shot, has anyone done research in an archives? Yay! A hand, all right. So I adore finding aids. I don't do archival research or research in an archives, but I adore finding aids because they are by humans, for humans solely, but they're so computational in structure. I love them. What they are is, so when an archives gets a collection, they have to process it. But like the stuff that can be in one of these collections is like wild. You can have like nested grocery bags of Post-it notes and like receipts, right? Could be one of them. And so you're like, how do I represent this in a data model? How do I represent a bag full of CVS receipts with like a book scrawled on the back, right? Like that's the kind of stuff that they get, and they have to like preserve it and keep track of it. People also need to visit and then say like, so everything is sort of cataloged into a box. And so what we have here is sort of the box number. These are letters to a dude. And here's sort of information about the letters. Letters lives inside of folders, and the folders live inside of boxes. We're going to dig into this a little bit more. It's just text, location names, IDs, and a lot of PDFs. Okay, hopefully we can see a common theme and problem here. There's no numbers happening. There's not even like a decent spreadsheet happening. So what happens when you're like, I've got some computationally cool data and I've got some Python skills and I see this awesome gallery of cool things I can do in Seaborn, okay? And I'm like, okay, I got cool stuff over here. I can do some fiddly bits over here. Let's make some cool visualizations happen. Well, This is my choice, right? Now, I wasn't expecting it to be 100% because that's not what visualizations are for. It's the reason why we have so many. I think we can agree, though, that this is like not a lot that I could do when I just have text data in here. So also, this was not a scientific review, so like don't at me that like, no, you could actually do a violin plot with that, so like simmer down. But like plus or minus a few, it's still not a ton I could do. Let's also look at some of the documentation around these things. So we have Plotly up here, Seaborn, and this is from the pandas documentation for Matplotlib. In red, we've got sort of some beautifully perfect data frame or tabular structure. And in like the sort of the magenta over here, we've got like, where are the numbers at in here? Now, also this one just says tips. Who knows what they mean by the tips data? Ooh, for the record, for the video, there's no hands. One hand, a couple. OK, there's your hands. Thank you. Yeah, so like, not a lot of people are like, oh, I definitely know the tips data set. I also know exactly how it's structured and the data model expectations and how it's formatted for it. Also, there's no link to the tips data set for like, what is that data? I don't even know. I have to Google it. Anyhow, also, this is a row. This is not even a column. There's just a lot happening in here. So these tutorials presume that data is coming in a well-formatted tabular file and is composed mostly of numerical data. Remember my data? I've got XML and PDFs and some sketchy spreadsheets. Okay. A novice coming into these things, so like a lot of us would know, because a lot of us are experienced in analytics across a lot of different platforms, that like, I think you really just have to like get all those things into a spreadsheet that looks fine. Like there's sort of that intuitive nature. It's not really intuitive. It's intuitive because it's been forced on us. Like from a novice perspective, why is it that we have to get everything into a CSV file? Like to me, XML, what I have is perfectly well structured, perfectly well formatted. Why can't I point Python to my XML file and make a bar chart off of that, right? Again, because the novice hasn't experienced these things yet. And so we're not making explicit that we expect data to be in a certain form. Okay? We're not making explicit that we expect the categorical column to exist. We're not making explicit that we expect like if you're familiar with the tidyverse, sort of like the tidy data format, we're not making that explicit in this documentation. It's what Seaborn wants, but like in the last page of their documentation actually says it. This is after someone's probably desperately copy and pasted. Who has like tried to make a cool tool work and you sat there with tutorials and you just literally copy and pasted to try and make any of it work on some data that you had, right? How many of you were successful? For the record, there's fewer hands, right? It's the same thing. So some of you bailed. Did anyone bail from that tool? Yeah, because it's hard, especially when you don't have a colleague next to you going like, and you can get like, what even is this thing, right? So there's a problem here, right? And again, I'm not criticizing the authors of this. I'm not criticizing the tools. It is hard. It is hard work, and I'm pointing out a thing we can improve on, okay? And I also want to acknowledge, like, okay, so most of the tutorials are teaching about the tools themselves, using canned data, focusing on the shortest example possible. And for many of us, that's not a bad thing, because the questions we're coming at it with are reference questions, like, is it type or kind when I do dot plot? I always get it wrong. So like that is an example of a reference question. Like I already have some data, I already know to use dot plot, and I know I can specify what type of plot I want, I just can't remember what attribute to use for it. But it's often not acknowledging that data also needs to be transformed into a specific shape. So there's two pieces of that. That it needs to be transformed, and two, into a specific type of format. Okay? Who's had to fight with melting data into just the right weird thing? Yeah? Like, that's totally normal. Okay? Do you remember it all the first time you encountered that? And you had to realize, like, oh, it wants that kind of column. Okay? These tutorials aren't making this explicit. I'm sure one of them does. Don't at me at that one either. So if we're producing tutorials with this voice of like, but you should already know how to do this, what sort of research are we leaving on the table? Who are we leaving out? Now, scope is important. But remember, there's a lot of different reasons that someone's going to use that tutorial. Not everyone using these tutorials that I highlighted earlier are going to be Python experts who are like, I've already got a data frame happening in my life. It's great. It's a great data frame. I just need to plot it, right? Like, that's not people's lives. Not everyone is going to think like, oh, clearly I need to transform these XML files into a well-formatted CSV with a specific kind of columns. Like, that's just not something a novice naturally thinks. They're like super focused on their data. They're like, I need to make a bar chart. I can like draw it for you. Please, Python, do this thing now. Like, they're not thinking through all of these steps if they haven't done them before. Now, why do I care about this so much? I'm going to read some nonprofit words for you. Let's take a visit to the Python Software Foundation mission statement. Okay, the mission of the Python Software Foundation is to promote, protect, and advance the Python programming language. Pretty clear, right? And to support and facilitate the growth of a diverse and international community of Python programmers. Okay, diversity is important to us. Also, the NumFocus vision statement, who is a sponsor of PyData, envisions an inclusive scientific and research community. Okay? This goes for our human bodies and human existence as well as our data. Okay? Inclusion and diversity is a core tenet of our communities, no matter which community you're coming from. Okay? Now, here's a series of questions. Okay. Do you believe that Python as a language is something different and uniquely important in the programming world? That's arguable, maybe. Okay. Do you believe in the power of open source? Yeah, I got a fist right there. Yeah, open source. Do you want as many people as who need it to be able to use Python in their work? Like, we're here at a Python meetup, so like clearly we kind of care about that, right? Do you believe that Python is a uniquely valuable language within the data universe? It does some uniquely cool things. So with this context, what if I told you that we're losing people? That we're missing out on entire populations of people? Okay? That's why this is important, because the core tenets of our community dictate that we should care. So I'm here to help you want to care, and later to give you some action items about how you can incorporate caring about this. Okay? I'm not saying we did this on purpose. It is natural. It happens. It is common to do analytics with numbers. That's stats presumes numbers. Like, that's fine. That's a thing. It's common to have spreadsheets and CSVs and databases. It's common to have some rectangles of data happening in your life for analytics. It is common to do some levels of transformation to that data for your analytics. All of these things are super common. There is nothing wrong with having that as a focus of your documentation and your tutorials and your tools, okay? But if this is all we can imagine the data in the world to be, we're lost, okay? And these are not even edge cases that we're dealing with. These are like entire academic fields that are like, my data will never look like that unless I just do a lot of things, or I have a GA who can just do a lot of things that I won't understand. Not that I even want to publish on something I don't understand, right? So remember the implications that I mentioned earlier? That we lose people who bail when they can't make the things work? When your data isn't part of the majority, which I would question, is it really not part of the majority, right? There's a lot of different data out there. You have to search for harder. You have to work longer. You have to work and rely more on unhealthy grit and dumb luck, okay? It should not require that a researcher has an unhealthy level of stubbornness and grit to be able to use open source tools, right? If that is an expectation that we're saying to survive this, you have to like have an unhealthy inability to quit. Like, I don't think that's good for us as a community, right? So where are the gaps? There's this gap of acknowledgement that this stuff has to happen, that this kind of data even exists, that ETL is a primary activity in our pipelines. There's also a gap in how we provide advice and suggestions. So let's go back to library world. Remember, I'm a trained librarian, right? That was also trained in data science. We have what we call reference interviews, which is sort of a very structured framework for like, who has ever gone to a reference desk in a library, middle school included, right? Okay, you asked a question and someone answered it. You may have been an undergrad, that's fine. But like librarians are trained to be able to field those kinds of questions. There's a certain framework of like, I hear you've asked me this. Do you maybe mean this kind of question? And then they give you tailored, customed advice. Okay, who here has asked a question of a colleague and 20 websites later, you're like, I'm gonna be done with this, thanks. And like, out, right? Sometimes we forget to shut up because we're so excited about things. And that's natural, but sometimes you gotta chill, right? So let's take this challenge. I come up to you, maybe I am a person in a tech meetup, and I'm like, I've got a bunch of like categorical data that's really cool, and I really wanna make a bar chart out of it. What do you think I should do? Think for a moment how you would react to that question. I hope positively because we're a wonderful, inclusive community, so let's start with that. But like, what's the first thing you would ask or first thing you would suggest? Just think about that for a second, okay? Who's thought of a tool? Like, oh, Seaborn makes cool bar charts. Who thought of a tool? Something like that. Who thought like, I think maybe Excel might actually be just fine for this, which might actually be the right answer. Anyone thought of Excel? That's fine, yeah. Did anyone think of asking me how my data was structured? Yeah, you get it, yeah. If we don't open with this, if we don't talk about these things, if we take them out of the conversation, if we take the data from transformations out of the conversation, then focus solely on tool use, like I've seen this a lot. They're like, oh, I want to do some data visualization, and they're like, Seaborn or Figure or something like that. Like, fine, those are fine tools, but not, that's like the end point of the conversation. That shouldn't be the majority of the conversation, unless I was like, which data visualization tool are you willing to fist fight about? So we're excluding people from the conversation who don't have data that cleanly fits for those tools when we don't talk about it, okay? Users still have responsibility here. You still have to like learn what a bar chart is. That's not open source's responsibility, okay? But presuming that a user magically knows to do all of those transformative actions will cause people to bail. And we shouldn't have people who are bailing because they can't make the doodads work, right? If it doesn't make sense for their science, that's fine. But if they can't make the examples work and that's why they're bailing, we've done a bad thing. We've got a problem, okay, that we need to solve. Okay, so who here is responsible for interviewing early career data science people? Okay, who here has encountered a student who like doesn't quite get that what I call life after Kaggle is that they think the data science workflow is I download data from Kaggle and I make cool models off of it. Yeah, and you're like, ooh, that's not life though. That's like Friday afternoon, right? Monday through Thursday is like actually trying to find where the data lives. Friday morning is maybe documenting it and doing a performance review and going to the doctor. And then Friday afternoon, I can actually build my models, right? If we are not acknowledging this transformative action of data within our workflows, we're going to be producing people who don't think that that's a thing, and then they're going to be surprised because it's totally a thing. If we do this, then we're failing at providing appropriate situated learning with our people. Okay, so what do you do? What do you do with non-numerical data? You mostly really just count things a lot in a lot of different ways. That's kind of what we got. To give you an example, I rewrote a SQL lesson from software carpentry for actually use with a finding aid with that pedigree data set. A lot had to get stripped out, like the entire chunk about calculating new values, because like recalculating Celsius into Fahrenheit, not a relevant activity for this sort of data. We had to take out a fair bit of aggregation as well. So like, what's the sum total of box numbers? Technically, I can calculate that, but it's complete nonsense. Min and max actually still useful to sort of see the range of values in here, but mostly we just do count and group by for stuff. You can do some visualization, but it's really limited to sort of EDA-like activities, which is exploratory data analysis. So anyone actually read the 1977 book for EDA? I love that people always quote it, but no one's actually read the book. It's beautiful. It's a fun book. There are a lot of essays about how to buy graph paper. It's beautiful. So let's look back at this finding aid, right? So this is the letters to Thomas Pettigrew. He did a lot of like Egyptology things. It's held in Yale University. There's 4.59 linear feet, 13 boxes, and a total of 21 boxes in the collection. We've got our spreadsheet. It's got numbers in columns. Right? This looks promising, so let's dig in. Okay, box numbers are numbers, and folder numbers, also numbers. The date column, there's kind of a lot happening in that date column. So like maybe that's something for a later day. We've got some extra lines happening, like in here where it's descriptive about this letter happening. Again, it's for people, not for computers. The headers, though, easily handleable. So let's read this into pandas. So here we're importing pandas. We're going to read Excel and then say skip those first 3 rows. We're going to use this drop NA to get rid of those sort of empty rows that we don't care about. And then we're going to take a look. And here we go. This is plausible, right? I've got like columns and there's numbers happening. So like I'm well on my way to making a bar chart, right? We've got numbers over here. That's clearly a number. I like it. And then here, we've got numbers. For those who are far away, we have 1.0 and then 1. To a pandas user, you probably know what's going on, that this got read in numerically and this got read in as an object because something wonky's happening, right? But would a novice pick that up? Probably not, probably less so. And let's try some of this documentation. So this is the pandas documentation on how to make a bar chart. Kind equals plot. On the row, there's just a lot happening in this tutorial that's not really explained. I get why it's just sort of wild. So I'm going to call .plot on one of my columns. And I get this, which looks like data, like there's something happening. So that's cool. But does it look like what I wanted? Doesn't stink right. Okay. This focus on the smallest example, it loses the context of what this data frame is. Because this data frame is like cumulative sums, and these numbers are literally in there already happening. And so they haven't had to do any transformative actions because they're trying to make the smallest possible example to work. And if you were just like, which attribute name do I use? Like, yeah, this would be helpful. Implicitly, they wanted me to do a group by to count. And if we do all of this nonsense, we can perform that action of count how many folders or how many lines there are for each box number in here. Okay? This is not trivial code for a novice. If you do pandas all day long, this is probably fine for you. Okay? But this is not trivial code to a novice or intermediate person. Okay? Index position is actually really interestingly valuable in this data set because the structure itself, going from the top down, is actually informative because you theoretically have like all of box 1, then all of box 2, and all of box 3, and you're like, I think that's true, but there's like 600 rows in here, and I'm not going to look through all of those. So you can see it sort of stepping up, which is actually pretty informative. You have down here the index position, and here sort of the numbers that it's seeing. And so you can see by this little step that, yes, it must be working in order. And you're like, cool, I've made some things that look like images. And I'm feeling good and confident. And then you try to go to the folder number. And no numeric data to plot. And your luck runs out. It's because what has happened here is there's a couple of the letters that live in multiple folders. And so there's a couple of instances in that folder column where it's like 542 through 552, something like that. So you have a couple of ranges in here. And so you have a choice, like how do I even data model this? There's a bunch of different choices for that. At sort of the most minimal, I can just delete them and then plot the rest and sort of see what's going on. You can sort of see these really no one else can except for me right now. But there's these little tiny blips here and here, but otherwise it's nicely linear, which tells me that against the index position that the folder numbers are actually running incrementally. Okay, let's move on to another example. So you have a pile of books in front of you. Can you tell what they're about and how they're connected? Okay. Can you do this computationally at scale? Because that's hard. So where can we get a credible report about topics in a book? Who's thinking, I want to do some topic modeling on descriptions from Amazon? Or like, I'm going to go to Goodreads and find some tags in here. If only there was a massive, freely accessible data source with authoritative information about books and an API that didn't require a key. Enter Library of Congress has the business, right? Now, subject headings across the world and all schemas are difficult. All taxonomies at some point in their lives have been racist. Do not try to come up with your own taxonomy because you're going to have super problems. Do you know that librarians are trained on how to make taxonomies and we still mess up, right? So taxonomies are hard. Subject headings have historically been difficult when it comes to race issues, but they're better than previous. They've been improved. At least so they're not perfect, but they are human curated and easily obtainable. Okay, so let's zoom in on a bit of this XML from one of these things that I gathered. So these are a bunch of 3 separate subject elements in here. And it's the topic nodes that I want inside the subject elements. This is the actual text, which are the subject headings for these books, or for at least this one book in particular. Goal, make numbers out of this, right? Can't make bar chart without numbers. But what are we measuring? So like there's letters here. Do I care about the S-ness? Do I care about the letterness, the characters of this? Is that my unit of analysis? No, I don't really care. Do I care about the words? Are the words my unit of analysis? Maybe. Are the tags my unit of analysis? Probably also. But also there can be 0 to many of these subject tags for one book. And also internally there can be a hierarchy of primary and secondary subject tag inside of one of them. So it's not a clean process. So we at least need to like grab, the first step is at least like, I don't know what I'm going to do with these words, but I should like extract them is probably the plausible first step. Enter bag of words. So what do you do when you have a whole heap of words and you're like, I guess I need numbers out of these things somehow? Bag of words are really what's come in handy here. We will talk a little bit about what a bag of words is when we sort of get to that point in the workflow. So a lot of non-numerical data starts off not intended to be data. I think that's beautiful. And I think that's where data science really needs to go, when we're generating insights out of things we never thought could give us data. I love the sort of trying to extract data out of things that are not data. So just to recap, this started off as a PDF of book titles and authors. It became a spreadsheet that a GA transcribed and then manually looked up ISBNs for. I grabbed that column of ISBNs, hit the Library of Congress. Of the 202 items, 156 had an ISBN. That makes sense because some of these were like websites that were printed off because prisoners can't have like all the internet access, so they just need a lot of paper because that's controllable. And so 156 both had an ISBN and a Library of Congress record. So I ended up with 156 XML files. Then from that, I created this matrix, this bag of words, after extracting the things from XML. So how do we calculate a bag of words? First, you have to like gain access to the text at question. In this case, I used XPath. And here, just grabbing the topic nodes and then extracting the text out of them. This is part of LXML. If you want to nerd out about XPath, please talk to me afterwards. I love it. You have to also somehow then detect the vocabulary from that text. So like gain access to the text and then pluck apart the vocabulary from it, from the entire corpus. So like of all the words that I see here, here are all the unique words. Count how many of those words appear inside of each document, and then slam all that business into a data structure of your choice. A lot of people do a 2-dimensional list. I used a list of dictionaries in this case. Whatever floats your boat, it's got to end up as a data frame at some point if you want to do cool things with it. So Bag of words is fun because once you have this, there's a variety of other calculations you can do on the corpus. A lot of them are used for feature detection and data mining and text mining applications. Like what this is like, if you've heard of TF, IDF, but not really known what and why, this is why. Like trying to detect powerful words for classification purposes. For us though, we just really want to see what's going on. We're sort of still solidly in that EDA stage. We're like, what are these books about? Clearly, there's some racist things happening, just like reading the first page of this PDF, but like, there's 156 books. There could be other things happening. So this is an example record. This is the title, and this is the unique key. I actually have no idea where this unique key came from. It was just in the spreadsheet and unique. Then these 4 things, I always keep the raw context, the original unprocessed data, just to like have it. I had the benefit of only having 156 books, so like I could keep all the business that I wanted. These are the unique words present across all of the subject headings. I stemmed the words, which sort of takes off. It actually didn't really take off anything inside of here, but it would have taken off pluralization and things like that. And it just does is reduce the total number of unique words, which reduces the dimensionality and the sort of the cluttery business that happens. And then I came up with the unique values of the stemmed words in here. And this just gives me like 4 separate data sets to kind of play with, to visualize, to see which one fits the best. And here we finally have, hey, howdy, look at those numbers. Yay, I have numbers finally, right? So of 156 books, there were 353 unique subject headings across them. So slammed all that business into a data frame. Using sort of, up here we have like a multi-index with that unique ID because some of the titles were actually repeated. So this is the unique ID and then the title. Over here we have the subject heading, and then here we have the counts. So for example, in this book called Research Matters, it had one subject heading of academic writing in here. And this, of course, continues on for 100 more, right? And then because I had my wonderful data frame full of beautiful numbers, then Seaborn was going to be happy with me. Hey, you got numbers, so here is a heat map. I wanted to make a heat map just to sort of see the overall spread of these tags. And I wanted to sort it so it wasn't just sort of like chaos all over the place. I wanted to sort from the top down the most common subject headings and tags. This heat map is actually using the stemmed values of the words and not the subject headings themselves because it was really long. Pretty like simple-ish to do if you know some data frame jamming. Sum the total numbers across each row of subject heading into a total column, sort the data frame by the total column, then ditch it so it doesn't like mess up my beautiful heat map, and boom, here we have a heat map for things. So that was a lot of work. Like individually, like this definitely took about 12 hours probably for this student to like go organize this spreadsheet. It took me 2 hours just to find a Library of Congress API that I could actually make work right with ISBNs, because that was all I had for the books. And then it took like another hour or 2 to like extract all the business out of the XML files. And like, I'm really good at things. So when I calculate how much workload it is for a novice student, I usually multiply my time by 10. So like if it took me 1 hour to do this, it would probably take a novice at minimum 10 hours. A lot of that being investigation time. Keep that multiplier in your head if you're an expert and you're dealing with novices, because it really changes the scale of how you think about time spans for things. Anyhow, yay, numbers, yay, heat map. So let's review what had to happen. It took a lot of transformations just to get literally any kind, like the number 1. It took a lot of work just to get to 1 in there. There's great documentation on how to generate a bag of words, but that presumed that I, A, knew I should use a bag of words model to calculate these things, and B, had full access to the vocabulary at question. A lot of those tutorials are just like, here's a canned data file of text, or we're just going to make up some fake sentences in there by hand, which is not real because you have to somehow read it in and make the business happen. Once we calculated the vocabulary, we had to force it into this rectangular shape into a model that I knew Seaborn wanted. I knew Seaborn wanted a data frame. I needed to get a data frame of numbers happening. Right. So the fact that I have to conform my data to the tool's model is one of those tacit things we're used to dealing with. But from a novice perspective, why can't the tool conform to my data model? Right? Both are equally plausible. We're doing a disservice to newcomers when we hide the transformations required to make the business happen in here. Now, this doesn't mean you have to teach them, but you should acknowledge that it should happen. Like literally one sentence, ensure you load your data and it looks like, I don't know, fake up a markdown table or something in there. Like you need 20 words to make this acknowledgement happen that would give people a prime like, oh, I do need to get my data transformed. Let me go take care of that now before I then just change this file name from your tutorial and desperately try to make it work. Here's your calls to action. Bring it home. Understand the point of reference versus instruction in here. Reference, for example, is, oh, what's that order of arguments again? And wait, is this a type or kind for .plot? This is where your extremely pithy examples come into play and are really valuable because as an expert, I'm just referencing what structure does this pattern need to have. Instruction is different. Instruction involves paragraphs, or at least sentences. A few sentences would be frankly wonderful to have. So no, you don't have to tell them what a bar chart is. They shouldn't figure that out on their own, that's fine. But you should explain what the data is you're bringing in. Explain what tips is. And provide a link so I can see what's the structure of tips. I can't assess whether or not I can do that visualization unless I can see what data it is that you're working with, okay? Random numbers are not universal data in there. If it's normal to aggregate the data before performing the analysis, the visualization, the tool, or whatever's going on, just say it. Like, BT Dubs, you should do a group by now, and then come back at me with something that looks like X, right? One sentence, really. It would really save a lot of people time and heartache. Show it happening, so it's an honest, authentic use case, okay? Don't just make a fake data frame that already has the aggregations, right? Because then the user thinks, like I thought when I was first learning R, oh, I need to run my analysis and then manually type in the aggregation data frame myself and then visualize that. Was that effective for my workflow? No, very bad. But I didn't know any better and I was desperate just to get anything done. So acknowledgement is important so people know there's that extra step so they can go seek out help. Because if you say, you need to aggregate your business here, they're like, oh, I don't know how to aggregate. Well, all of a sudden, they have a well-formed query to come to a tech meetup and say, I'm not sure how to aggregate data in pandas. That's a really well-formed query, right? Versus, I can't make a bar chart happen, help me please, right? Which one would you prefer? Probably the first one, yeah. Recognize also that users with text data have unique data preparation needs and differing data structures. Be really clear about your model expectations. This goes for internal documentation too. Like if you're like, I'm expecting this tool expects your data to look like blah, make a fake version of it or something. You can do it in a markdown table, right? That's kind of what I have. Just sort of be awesome to each other and admit that you have to do more than just the smallest example possible in your tutorials. Okay? I have no idea what time it is. Cool. That's what I have.
We have some time for some questions.
Hey, in the back.
Any summary conclusions about the 202 books? I saw a lot of African American social in the email.
Can you repeat the questions?
Yeah, so there was a question about the results of my analysis of subject headings, which is super preliminary and actively current work that we're going to address more next semester. It appears to be a lot about race. They appear to have gone through a couple syllabi for critical race theory classes and just yanked a lot of those books. But there's also books on religion and schizophrenia and the prison system and a lot. There's just a lot happening in there that needs more qualitative analysis, but certainly, as you saw in here, the top words appearing are American, African, social, history, race, relations, conditions, politics, prison, discrimination, etc. In here. Yep. Yeah, there's a lot of reasons.
Or where did you get the stop word?
I looked at the data and came up with what was a stop word in that data set. So I just reran it. I was like, I think it only took out about 5 stop words, which are like the, and, of, in, etc. Yeah. But I did it just sort of, actually, I didn't just bring in a generic stop word list. I just looked at the actual words and popularity of the words and pulled the stop words directly from the data. Yep.
I suspect if you were to like go to Seaborn and in these other libraries and say like, these are things that we could do to make these documentation libraries more beginner friendly, the sort of obvious comeback might be, well then that's sort of that's sort of taking a different point in the continuum between like being beginner friendly and being user friendly as like a reference document. So I'm curious if you could talk at all about sort of that continuum. Can documentation be all things to all people? How do you choose sort of where to sit on that continuum?
Yeah. So I have 2 answers to this. The first one is I tried. I actually put in an issue into the Seaborn documentation, and I was like, can you put your acknowledgement of tidy data format at the beginning and not at the end? I'm willing to do it. I'm just not sure like which thing it's coming in from, because it was like it was not really sure what was happening. And the response was, no, thank you, because we've thought about it a lot, and they closed the issue. So, okay, sure. But yeah, balancing that tension between like what is reference and versus instruction is difficult. I think, again, it's not the responsibility of open source maintainers to like teach people what a bar chart is, but at a minimum, you could put a sentence of like, here are expectations for this usage. If you're showing a bunch of examples of people hitting a data frame, like say the data frame should have a column like this and a column like that, and just say like in natural human words, get your data into this order somehow, or like have a column where all of your categorical labels live inside of a single column, like simple 1 sentence in there, and it's like bullet points would be totally fine. And so it doesn't have to be a ton. What you're looking for is aiming at like, what are the most minimal prompts required to like appropriately halt someone in their tracks and to say like, oh, I didn't do that. Oh, I don't have a CSV. Oh, I have 156 XML files. I guess I need to sort that business out. Just acknowledge your required business rules. Again, it doesn't have to be long, but like that's what I would start with first. It's just like, can you come up with 5 like expectations before you get started in this tutorial? And if you can, take it a little step further and say like, here's some tutorials for like how to get there in there. Here's like, or here's a pandas documentation that like works really well for this tool or something like that. But at a minimum, just say what you want. Yep.
So I'm the person who doesn't know how to like sort my data. So do you have any suggestions of where I can look before I start trying to get into all of this?
It depends on sort of where you're at, whether or not you're beginning to programming or you're beginning to Python, or you're just beginning to pandas and you already have programming in Python inside of there. So get really good at Googling, but don't just get good at Googling, get good at assessing the results. Like we talk about this in like freshman year research, right? Where like you type in Civil War into Google and you get some results. You have to like, first off, look at the URLs coming up. Because if it's like datasciencetutorials.com versus like pandas.org, like one of those is going to be a little bit more authoritative in there. Also look at dates as well, especially with Stack Overflow posts, because pandas is an ever-changing landscape. And there's certain like deprecated cleverness in the language that still exists. So if you hit a Stack Overflow page that's like I usually caution about 5 years plus old, you probably want to try and look for something a little bit newer because the language has evolved a little bit more. So look at the source, look at the date. When you're looking at Stack Overflow, don't read the title, don't read the user's question. Go straight down to the first answer and only read the code. And if the code doesn't help you, move on, right? Have trusted people around you to help out with things, and don't be afraid to ask questions. I learned alone because I stubbornly refused to ask for help, and it was inefficient and traumatizing. And so you're gonna have to find resources that speak well to you, but keep good notes as well. And remember that it's like a non-linear process. So especially with pandas and other tools and frameworks, using something like XMind or like a mind mapping tool to take notes and making a little mini reference database that makes sense to you, I think is one of the best ways to do it.
Leverage the community too.
Yeah, so come here and ask questions. Keep a list, keep a Google Doc of like, or something on your phone of like questions to ask the next Python person you see. So.
Maybe one more question.
Sure.
I mean, it's kind of on the edge of discussion and question. But thinking about your life after Kegel analogy and the week, I'm trying to wrap my mind around your thesis, and that is we need to take the message that's still in an ETL that needs to happen before you get to the point of analysis, because the stepping stone to knowledge and value, right? So we need to like remind people in tutorials that they need to do a lot of ETL before they get to that point, or is it we need to build the tools that don't like only read rectangular tables?
It's fine that we expect CSVs and data frames. That's not necessarily a bad thing. It'd be cool if it did something else, but like, it's fine to have certain expectations and requirements for a data model for your tool. What's missing though is a coherent, from many, is a coherent discussion of those expectations for it. So like Matplotlib's expectations for doing visualization versus Seaborn's expectations for data structure in there. Be clear about your expectations of like, for this tutorial to use on your own data, you should plan on being able to load text files into something. So something like that. So like take a moment when you're saying, here, I'm gonna load this canned data, I'm gonna load it into this specific kind of structure. And just be clear, have a couple sentences about like expectations about that. And don't just like, wham, I'm gonna load tips and we're gonna do visualization. Like you should be at least a little bit more.
So as we wrap up here, I just wanted to stare at your camera to say thanks to Michael Kennedy as well as Matt Harrison for giving us those 2 books on PyCharm. But also as an open source package maintainer myself, I've been inspired that I need to do at least a little bit better and try to be inclusive, and also the things that we're leaving on the table or the people that we're leaving out, right? So let's thank again Elizabeth for a great talk.
Yeah. Thank you. Thank you.